we're going to look at the built-in data structures in Python, which are extremely important when building real applications. First, we're going to look at lists, and then we'll look at tuples, sets, and dictionaries. So earlier you have seen that we can use square brackets to define a list or a sequence of objects. In between these brackets, we can have objects of any type. So we can have a list of strings like this, and then assign it to a variable like letters. We can also have a list of numbers, booleans, or even a list of lists. Let me show you. So here we have a list. Each item in this list will be a list itself. So here's the first item, which is a list of 2 items. Now let's add another item to our main or parent list. This item is also a list with 2 items. So now we have a matrix, which is a 2-dimensional list. Now let me show you some cool tricks. Let's say you want to have a list of 100 zeros. You don't want to manually create that like this. That's very ugly. Let me show you a better way. So we define a list of 1 item, 1 zero, and then we can multiply it by 100. And the result will be this. Let me show you. Print zeros. Here it is. There you go. So using a star or an asterisk, we can repeat the items in a list. Now, similarly, we can use a plus to concatenate multiple lists. Let me show you. So first, I'm going to change this to 5. Now, let's define a variable combined, which is our zeros list plus letters. Let's see what happens. Print combined. You know it. So we have 5 zeros followed by A, B, C. As you can see in Python, every object in a list can be of a different type. So they don't have to be exactly the same type. We can combine a list of numbers with strings and booleans or even lists. Now, let's say you want to have a list of numbers like 0, 1, 2, 3, all the way up to 20. You don't want to type all of these by hand. There is a better way. So we have this list function. As you can see, this function takes an iterable. So we can pass any iterable here and convert it to a list. Earlier you learned about the range function. This function returns a range object which is iterable, which means we can iterate or loop over it. So here we can call this function and pass 20. And with this, we can create a list of numbers from 0 to 20. Let me show you. So let's store it in numbers and then print it on the terminal. There you go. So 0 up to 20. But note that 20 itself is not included. As another example, let's call the list function and pass a string. Earlier, I told you that strings are also iterable. We can loop over them. So we can pass them to the list function and see what we get. Let's print chars on the terminal. So you can see each character in our original string is an item in this list. So these are a few different ways to create a list in Python. Now that we have a list, we can get the number of items in that list using the len function. So here we can print the len or length of chars. Let's take a look. So we have 11 items in this list. Over the next few lectures, we'll look at various operations around lists. So here we have a list of 4 items. We can use square brackets to access individual items in this list. So let's print letters of 0. This will return the first item in this list. So when we run this program, we'll get A. Now, similar to strings, if we pass a negative index here, like -1, this will return the first item from the end of the list. So when you run this, we'll get D. Using square brackets, we can also modify items in the list. So let's change the first item to a capital A and then print the entire list. There you go. So this is the basic of accessing individual elements in a list. Now, earlier in the course, you learned that we can use 2 indexes to slice a string. We have the exact same concept here. So we add square brackets, first index, colon, second index. And this will return a new list with the first 3 items in our original list. So if we print our original list, you can see that it's not changed. Now, just like strings, if you don't specify the first argument, 0 will be assumed by default. So as you can see, these two expressions produce the exact same result. Similarly, if you don't include the end index, by default, the length of the list will be used here. So this expression will return a new list with all the items in the original list. And similarly, we can also exclude the start index here. And with this syntax, we can get a copy of our original list. There you go. Now, when slicing a string, we can also pass a step. And this is useful in situations where you want to return every second or every third element in the original list. So now when we run this code, we'll get A and C. So B will be skipped. Let me show you using a better example. So I'm going to delete everything here. Create a new list called numbers. Here we're going to use the list function and pass range of 20. Let's print our list. So we get numbers 0 to 19. Okay. Now let's see what happens when we add square brackets here with 2 colons and 2. This will return every other element in the original list. Take a look. So we get all the even numbers, 0, 2, 4, and so on. That's pretty cool, isn't it? Here's another cool thing you can do here. Let's change the step to -1. As you can see, this will return all the items in the original list, but in reverse order. So these are some useful things you can do with lists. Next, we'll look at unpacking lists. There are times that you may want to get individual items in a list and assign them to different variables. Here's an example. We can define a variable like first and set it to numbers of 0. Similarly, we can define second, set it to numbers of 1, and third, set it to numbers of 2. Perhaps you're going to use these variables in a few complex expressions in your code. Now, there is a cleaner and more elegant way to achieve the same result, and that is what we call list unpacking. So we can unpack this list into multiple variables. Let me show you how that works. So we define our variables like first, second, and third, and then set them to our list. What we have on line 2 is exactly identical to what we have on lines 4 to 6. This is what we call list unpacking. Now, what is important here is that the number of variables that we have on the left side of the assignment operator should be equal to the number of items we have in the list. So if we exclude third here and run this program, we will get an error. Value error, too many values to unpack. So there are too many items in this list, and we cannot unpack it into enough variables. Now, what if in this list we have so many items, but we only care about the first 2? We don't want to define so many variables on the left side of the assignment operator. Well, we can get the first and second, and then pack the rest inside of a separate list called other. With this syntax, we'll get the first and second items, and everything else will be stored in a separate list called other. Let me show you. So let's print first, and let's also print other. Now, we don't need these few lines here. Let's run this code. So first is 1, and other is a list of all the items after the second item. That is the list I'm talking about. So in this example, we have both unpacking and packing. First, we try to unpack this numbers list into the variables on the left side of the assignment operator. And then because we have used an asterisk here, we're basically packing all the other items into a separate list. Now, to refresh your memory, earlier we used this syntax when defining a function with a variable number of arguments. Remember? We had a function like this, multiply, with a parameter called asterisk numbers. And then we could call this multiply with arbitrary number of arguments. So when we prefix a parameter with an asterisk, Python will get all these arbitrary arguments and pack them into a list. This is exactly what is happening on line 2. Now let me delete this other stuff. Now let's change this example a little bit. What if we care only about the first and the last item? Well, we can put other in between, so we get the first, other, and then the last item. So let's change the last item to 9, and then print first, last, and other. This is what we get. So first is 1, last is 9, and the rest is here. So this is all about list unpacking. In this lecture, I'm going to show you how to loop over lists. So here we have a list of 3 items. We can use our for loops to loop over this list. So for letter in letters, colon, and then we print each letter. Save the changes and run the code, we get A, B, C. Now, what if we want to get the index of each item as well? Well, we have a built-in function called enumerate. We call it here, and this will return an enumerate object, which is iterable. In each iteration, this enumerate object will give us a tuple. Let me show you. So now when we run this code, look, in each iteration, we're getting a tuple. So a tuple, as I told you before, is like a list, but it's read-only. We cannot add new items to it. So in each iteration, we're getting a tuple of 2 items. The first item in this tuple is the index, and the second item is the item at that index. So now to get the index, we can use square brackets to access the first item in this tuple. So if we print letter of 0, we will get the indexes, and right next to that, we can add letter of 1. So we will see the item at a given index. But this syntax is a little bit ugly. In the last lecture, you learned about list unpacking. So if we have a list with 2 items, 0 and A, we can unpack it into 2 variables like this: index, comma, letter equals items. So here we are unpacking the items list. Now, what if we change square brackets to parentheses? Now we have a tuple, and we can still unpack this tuple. So you saw that this enumerate function returns an enumerate object which is iterable. In each iteration, this enumerate object will return a tuple that looks like this. So we can unpack it right here. So we add another variable, index. Now with this, we no longer have to use square brackets, and we can simply print index and letter. Let's run this code. There you go. So now we don't need this anymore. So to recap, you can use for loops to iterate over lists. If you also need the index, you should call the enumerate function. This will return an enumerate object, which is iterable. In each iteration, it will return a tuple, and you can unpack that tuple right here. In this lecture, I'm going to show you how to add new items to a list or remove existing items. So for adding items, you have 2 options depending on where you want to add this new item. If you want to add an item at the end of the list, you should use the append method. So earlier you learned that everything in Python is an object, so you can use the dot notation to access individual functions, or more accurately methods, in that object. So when a function is part of an object, we refer to that function as a method. So here are all the methods available on list objects. We use the append method to add something at the end of this list. Let's print our letters, and we will get A, B, C, D. Beautiful. Now, if you want to add an item at a specific position, you should use the insert method. So letters that insert, we can add something at the beginning of the list. So index 0, let's add a hyphen, and then print the result. So this is what we get. Now for removing objects, again, you have a few different options. If you want to remove the item at the end of the list, you should use the pop method. So here we call letters.pop. This will remove the letter D at the end of our list. So now let's print our letters. As you can see, D is gone. You can also pass an index here to remove the item at the given index. So if we pass 0, instead of D, this hyphen will be removed. Let's take a look. We run this. So the hyphen is gone and we get ABCD. Beautiful. Now there are times that you want to remove an object, but you don't know its index. If that's the case, you can use the remove method. So letters.remove. Here we can remove B, and this will remove the first occurrence of the letter B. So if you have multiple B's, only the first one will be removed. If you want to remove all B's in this list, you will have to loop over this list and remove each B individually. Now let's run this code one more time. So you can see B is gone. We have another way to remove an item from a list, and that is using the del or delete statement. So here we can delete an item by its index. We can also delete a range of items. So this is the difference between the delete statement and the pop method. The pop method will remove only one item by index, whereas with the delete statement, we can remove a range of items. And finally, if you want to remove all the objects in the list, you should use the clear method. Next, we'll look at finding objects in a list. There are times that you want to find the index of a given object in a list. So let's say we want to find the index of letter A in our letters list. We call letters.index and pass A. Let's print the result. So this will return 0. What if you try to get the index of an object that doesn't exist here, like D? We get a value error. D is not in the list. This behavior is different from a lot of programming languages out there. C-based languages return -1 if you try to get the index of an object that doesn't exist in the list. But in Python, we get an error. So to prevent this error from happening, first you should check to see if the given object exists in the list. And for that, we use the in operator. So if D is in letters, then we will print its index. So now we run the program and we don't get any errors. We also have another method that you might find useful in certain situations, and that is count. So letters.count. This will return the number of occurrences of the given item in this list. So when we print the result, we'll get 0. Hi guys, thank you for watching this tutorial. My name is Mosh Hamadani, and I have tons of tutorials like this for you on my channel. So be sure to subscribe, and also please like and share this video. If you want to learn Python properly from scratch with depth, I have a comprehensive Python tutorial for you. The link is below this video, so click